multiply evenly into other numbers is called a common factor. The greatest of these commonalities is the greatest common factor. Yet when letters are involved, we need to think small, include the lowest power. Now it's time to take the GCF with factor. Factor it. Now we find the GCF. That's factor, y'all. Write it out from parentheses, compare. Parentheses. Divide each original term by the GCF. Factor. The resulting terms go into the parentheses. Now it's not just another kind of factor. Wow. A second-degree trinomial is also called quadratic. If it starts with the 1, then you won't see the 1. The factoring's automatic. You need to think of two numbers that add to the middle and multiply to the last. Like start with the letter and end with the numbers. Yeah, factoring is a fact. Well, we see 4 terms without the GCF instead of the There's a simplified fraction. Wow. These quadratic trinomials start with something other than 1. We still must think of two numbers, but this time around it's a little tough. Our numbers must add to the middle and multiply to the product of the first and last. Take the numbers that right two middle terms, flip the expression, use grouping to finish the task. Factor now.
Alright, well, welcome back, Algebra 1 students. We're looking at factoring, of course, as you can tell from that video. Now, I know that video might have been going really fast and might have been very challenging maybe to understand really what to do, and we're going to take it kind of one step at a time as we go through these factorings. We've already done the first two, really, the GCF factoring. We're going to do a little bit more of that again today, looking for a GCF to factor out, because that's always the first step in factoring, is to look for a GCF first and factor that out. And then we also factored with a simple method. Just when you had an x squared, it was just a 1 in front of x squared. We saw that on the last lesson. And now we're going to be looking at when there's a, as you can see here, factoring the ax squared. That's the only difference here now, is there's going to be a number in front of the x squared. It's going to make it a little more difficult, more challenging for us to factor these. All right, so here goes with our cartoon. So a cat comes up to a, looks like a gumball machine, but it's apparently a mouse machine. One of the mice, Randy's going down! Poor Randy. Guess he got sucked down into the, whatever that is there. The cat's going to get Randy. All right, well, moving into our factoring out the GCF. So let's just remind ourselves about that first, because we're going to see the first problems just like this. So we have a trinomial in this one, and really it doesn't matter how many terms you have. It could be just 2 terms, it could be 3 or 4, it doesn't matter. We always want to look for a GCF first. This is always step number 1 in factoring. And in this case, we want to look for numbers and letters. Right now we're just going to see numbers being factored out, but sometimes you might see also letters, and that the video actually showed you one with letters coming out as well. So in this one you can see 5 can go into all 3 of these numbers, so 5 can come out. So our term here then is going to be like this. 5 is going to be out of the parentheses in red here, and what's left now, you basically are dividing every term here by 5 to figure out what's left. So I divide 5 by 5, it's a 1x squared. 15 divided by 5 would be 3x, and 10 divided by 5 is 2. All right, and that's what's left. And so you should have the same number of terms in the parenthesis that you had here in your trinomial. If you were to multiply 5 back into here, we should get back to our original trinomial. All right, let's go ahead and take a look here at page 232 there in your notes. So page 232, we'll take a look at 1 through 3 first, and then I'll have you try 4 through 6 on your own. And I wrote down kind of the steps. First, we're going to factor out the GCF, and then use simple method factoring. That's basically all we're doing here on this one. So first is to factor out GCF, and then like we did in the last lesson, we're just doing simple method factoring. And so on number 1, 2, 14, and 36, 2 can go into all these. So obviously it couldn't be something bigger than 2. It can only be 2 or smaller, and so 2 can come out of all of this. And so then we're going to see what's left. From the first term, it's just a c squared left. And then we put the minus sign. 14 divided by 2 would be 7, so 7c in the next one. And then 36 divided by 2, that's going to be 18, so 18 there at the end. And if you multiply back in, we would just get up back to our original. And so now we want to use simple method factoring to factoring the trinomial here. So we're going to keep the 2 still on the outside, but now we're going to put 2 parentheses for 2 binomials. C squared is going to be C and C. And two numbers that multiply to give us 18. Remember, that's our question. Two numbers that multiply to give us 18. And they also have to subtract to give you 7. So the same two numbers that multiply to give you 18 also have to subtract to give you 7. So you can think of 6 and 3, but 6 and 3 will not subtract to give you 7. 9 and 2 is also another combination to multiply to give you 18, and they do subtract to give you 7. So 9 and 2, they are going to be different signs since you're subtracting, and the bigger number, 9 between 9 and 2 is bigger. 9 is going to get the middle sign. So it's going to be negative for 9 and a positive for 2. So there's your two binomials, C minus 9, C plus 2. You could even check to see that's correct by doing FOIL, the FOIL technique. First term should give you C squared. Outside is 2C, inside is negative 9C, and if you combine those, you get the negative 7C. And then negative 9 times positive 2 does give you negative 18. All right, so let's move on to number 2. We'll do this one in green, maybe. So number 2, 4, 8, and 140. So basically, we know 4 goes into 8. Does a 4 go into 140? You know, we could check that really quick there. We'll just do a 140 divided by a 4. And that is going to be, what, 3 times there? That's 12. And then 2, 0. Yep, it does, 35 times. So definitely we can factor out the 4 since 4 can go into all three of those numbers. And what's left in the first one is just a squared. And if I say 8 divided by 4, that's going to be 2. So 2a in the middle minus. And then the 140 divided by 4 we saw was 35. So 35 just right up there. And so now we keep the 4 on the outside still. We don't want to lose our GCF. And then we're going to factor this using simple method with two binomials. Again, the a's, that's the simple part, is just a and a go up in front. Then you ask yourself the question, what two numbers multiply to give you 35 that subtract to give you 2? And maybe you might be thinking 5 times 7 is 35, and yeah, the difference of those two numbers is 2. So that would work. 5 and 7 are the two numbers. They multiply to give us 35 and they subtract to give us 2. Since it's a different, they have to be different signs since we're subtracting, the bigger number 7 is going to get our middle term sign of positive, which means 5 is negative. Again, you can check it by even outside right here, you're going to get 7a, inside's negative 5a. That will combine to give you a 2a. So there you go, there's your final answer on that one. And then number 3, we see on this one, 3, 6, and 24, we definitely know 3 goes into all numbers here, so 3 can come out. X squared is still left in the first term. 6 divided by 3, so it's going to put a minus there. That's going to be 2x, another minus sign there. 24 divided by 3, that's going to be 8. And then again, we're going to keep the 3 on the outside and put two binomials down. The x's go up in front, that's the simple part. The two numbers that multiply to give me 8, that will subtract to give me a 2. 4 and 2 would work. You could put 4, 2 or 2, 4, that doesn't matter. We are subtracting, so it means we're going to have to get different signs in here. The bigger number 4 will get the middle term sign. So negative goes there, which means positive is for the 2. And you can just always double check, especially outside, 2x, inside's negative 4x. And if you combine that, you will get negative 2x. The last ones multiply to give you the negative 8. So that's true on that one. So there's our answer for number 3. And here's our answer for number 2. And then our answer for number 1. So our answers are just like that. That's the way you want to get these answers for 4, 5, and 6. So first, just do the 2 steps, factor out the GCF first, and then use the simple method factoring to factoring the trinomial to 2 binomials. Let's go ahead and pause the video and do 4, 5, and 6, and then I'll show you those answers once you play the video. Alright, so hopefully you have answers now for 4, 5, and 6. So for number 4, the factoring out, you'll be factoring out a 2. So the first thing is factor out the 2. And so it gives you d squared minus a d minus 30. And then simple method factoring for this here will give you your answer. 2 still on the outside. D and d go up in front. The two numbers that multiply to give you 30, that will subtract to give you a 1 is 5 and 6. And since they're different signs, that means 6, the bigger number is going to get the sign on the middle sign there, which means 5 is positive. Number 5, we can see we're going to factor out 5 from those 3 terms, of the 5, the 55, and the 50. And so that gives you an s squared for your first one plus 11s plus a 10. And then keeping the 5 outside, two binomials right here. The two numbers that multiply to give you 10 that will add to give you an 11 is just 1 and 10. 1 times 10 is 10 and 1 plus 10 is 11. They're both the same sign. They're both going to be positive. This is a positive here. You're adding to get this term. Then both signs will be whatever this term sign is. They're both positive then. And then number 6, we can see 3, 30, and 27. 3 can come out of all three of those numbers. And so 3 comes out. What's left in our first one? Q squared. And then you have a 10Q from the middle. And then 9 for your last one. And then we're going to just keep the 3 on the outside. Q's go up in front. The two numbers are 9 and 1. They multiply to give you 9. They also add to give you the 10 because we're adding to get this one. Then they're both this sign when you add. So whatever this sign is, if this was a minus, they would have both been minus. So if this is a adding to get the middle term, it's going to be both what the middle term sign is. All right, so hopefully you got those correct. And this is a little bit of the easier part. We're going to get a little more challenging here as we go forward, because now we're going to get into factoring out the ax squared. Now there's going to be a number in front, and we're not going to use the simple method. We're going to use the star method. So the star method starts with just the star. So you want to, on page 231, there's a notes section right there on page 231. And you want to kind of copy this whole thing down on that notes section on 231. So you just put the star in. You put an X and then a line straight through the middle. That's your star. And for this term right here, for something in this form where you do have a number in front of the x squared, you're going to put a times c. You're going to multiply the first number and the last number. Those are always going to be numbers. A times c. So multiply first and last numbers for the top of the star. And then the middle number here, whatever that middle number is in front of this x, that's going to go at the bottom of the star. It's the middle number. So b goes down there, whatever number that is. And if it's a positive, I put plus. If it's a minus, I put minus. Same thing I do up here. If I'm going to be multiplying and it's going to be positive, I put plus. If it's a minus, I put minus. Now the top of the sides of the star here is just how this begins. So it's the AX. So whatever number, and then obviously you can use a letter here. If it's X, it's X, or it could be some other letter as well. So A and then the variable. The number and variable of the way this trinomial starts goes on both sides. It's just the same exact thing. And then underneath those, I put question marks here because that's where you're asking the question, just like we asked in the simple method, which is what two numbers multiplies to give you the AC on top, that will add to give you the B number on the bottom. So as long as this is positive, it says when C is positive here, and you have a plus here, that means you're going to get a positive here. They have to add to give you this, because you're going to multiply positive times positive, giving you a positive then for your top one. So that means you're going to be adding to get this number down here. What two numbers multiplies to give you C, that will add to give you the B number. Okay, and that's what you're doing. Once you do that, you'll be able to figure out what those numbers are and what the signs for them are. And then you want to see right here, it says reduced sides gives you your binomials. Remember, we're trying to factor this to two binomials. So the two binomials that we will get are on the sides here. Now the way the video showed it to you was a little bit different. The video actually showed you something similar to this, but I like the star method because it really kind of organizes all of that for us in this kind of star graphic here. So I think this is actually a really helpful thing, and I think you'll like this as we go through it. All right, let's go ahead and try some now using the star. So number 7, I'll do 7 and 8, and then I'll have you try number 9. So number 7, notice there is no GCF. That's the first thing. You still want to look for that. You still want to look for a GCF to see if there's any greatest common factor that can be factored out first. 12, 37, 28. There is no GCF between those. Even the letters, they would have to have a G in this last one in order to factor out a G. So there's nothing to factor out. So we're just going to start with now figuring out what's going to be in here. Now we're going to start with 12 times 28. 12 times 28, something, quite of a big number. We can multiply it on the side. I'm just going to use a calculator for that, just to do it really quickly. So 12 times the 28 is going to give us 336. So that's the top of our star, and it's a positive. So I'm going to put positive 336. The B number is negative 37. That's going to go on the bottom of the star. And then the top of each side is just the way this begins, 12G. 12G here, and a 12G going here. So now this one is a challenging one. These other ones are going to be a little bit better, just because we have a pretty big number here with 336. We need to figure out what two numbers would multiply to give us the 336 that will add to give you 37. Well, we already know, one combination, that's 12 times 28. You already know that multiplies to give you 336. Would they add to give you a 37? Well, that would be a little much. That would actually give us 40. But we're not too far away from that. We're not too far away from looking at that. So we want to kind of stick around the numbers here, so something close to those numbers perhaps. Let's maybe try, and using the calculator, I'm going to try a couple things here. Let's go ahead and try something maybe a little bit bigger than 12. We could try 13. That's one number we can try, so I can do 336 divided by 13. What does that give me? Okay, it doesn't give me a whole number, so it can't be 13. Let's try again 336 divided by the next number, 14. What does that give me? 24. Okay, so now I got two numbers, 14 and 24. 14 times 24 times 24. Will those add to give me 37? Let's see, remember these added and gave me 40, right? These numbers are going to add and give me, let's see, that's going to be 28, 38. I'm really close. So I'm very close to this, but it doesn't look like it's right yet. So let's try something else. So 336 divided by 16. 21. So 16 and 21 also, 16 times 21. If you add these two numbers, when we're trying to add them to 37, that does give me 37. So these are the two numbers. Those are the ones we want. So I'm going to go ahead and erase that there. I'm going to put the 16 and the 21 now down underneath 16 and a 21 down there. Okay, what's the sign supposed to be now for those? They're supposed to be, since we're adding, they're the same sign. They're both going to be the sign of the B term. They're both going to be minus. And now what we need to do is we see this kind of as a fraction. We want to simplify our fraction with the numbers here. 12 over 16 can be reduced. I can reduce this by 4. 4 goes into 12 3 times, so I'm going to get a 3g on top. And 4 goes into 16 4 times, so a negative 4 on the bottom. So now that one is reduced. And then over here, 12 and 21, I can reduce by 3. 3 goes into 12 4 times, so 4g on top. And 3 goes into 21, so this will be negative 7 on the bottom. So now this one is reduced. And now the reduced sides are your two binomials. So remember, our goal is to factor this to two binomials. So 3g minus 4, right here, minus 4 is one binomial. 4g minus 7 is the other binomial. So it's very easy once you get to this point, just plug them in the binomials. The hardest part here is going to be figuring out that question. What two numbers multiply to give you 336 that added to give you 37? It's really only hard because the number was big. Let's look at this next one and we'll see it's a little bit easier here because the numbers are going to be smaller. So A and C is 6 and 4. Multiply 6 times 4. Those two numbers, multiply them, and we get 24. So positive 24 on top. I always like to put the sign there in front of it so I know if I'm going to add or subtract. The B number is right here, negative 11. So negative 11 goes on the bottom. And the way this begins is 6k. So 6k goes on top of each side. And now we ask the question, what two numbers multiply to give us 24? That will add to give us an 11. So a little bit easier because the numbers are smaller here. And we can think, well 6 times 4 is not going to add to give us an 11. It would add to give us 10. How about 8 and 3? So 8 and 3 They multiply to give us 24, and they also add to give us 11. The sign is going to be whatever sign this is. They're both going to be the same. They're both going to be the sign of 11, which means they're both minuses there. Now we want to reduce your sides if you can. If you can't reduce them, then that would be your binomial. But since 6 over 8 here can be reduced, and we can reduce both of these by 2. 2 goes into 6 3 times, so 3k there, and 2 goes into 8 4 times, so negative 4 here. So there's my reduced fraction on that one, or my reduced side. It's not technically a fraction. 6 and 3. 3 can go into 6, so I can reduce by 3. 3 goes into 6 2 times, so 2k on top. And 3 goes into itself once, so negative 1's on the bottom. So there's my reduced side right here. And so now we'll see, let's see here, my 2 binomial, that's what I want. 2 binomials, so this binomial here is going to go into one of them. It can go into the first or second, it doesn't really matter. So, but one binomial is 3k minus 4, and the other one's going to go in the other binomial, 2k minus 1, and we are done. How could you make sure that you're correct? You can always check this by multiplying these two to get back to your original trinomial right up here. If you multiply your first term, that should give you 6k squared. Outside is a negative 3k, inside's going to be negative 8k. That would combine to give you the negative 11k. And the last one's multiply negative 4 times negative 1 to positive 4. So you know you're correct when you can just FOIL this, you multiply with FOIL and you get back to your answer. So that was our answer here on number 8. Here's our answer on number 7. And now I want you to try on your own. Go ahead and try number 9. So see if you can do number 9 correct using the star method. Start with multiplying 9 times 2 for the top of the star. All right, go ahead and pause the video, do number 9, and then just check your answer by playing it. All right, so hopefully you have an answer here for number 9. Let's go ahead and check to see what your answer should be. Your answer here, I'll just show you the answer first. Your answer should be this: 2 binomials, 3w plus 2, and a 3w plus a 1. They don't have to be in that order. This one could be first, that one could be second, but you need to have those 2 binomials. Okay, so if you got those correct, that means you probably did your star correct. If you didn't get that correct, let's take a look at what the star should look like. So you're multiplying the A and C's, that gives you positive 18. B is positive 9. And it starts with 9w on each of those sides there. And so then you're going to ask yourself what 2 numbers multiply to give you 18. That add to give you 9, that's a 6 and a 3. And they're both the same, they're both positive. Positive 6, positive 3. And then this reduces here by 3. 3w over the, and then a positive 2. This one reduces also by 3, so 3w and a positive 1. And those are your 2 binomials right there. All right, so hopefully you got the hang of the star a little bit. We're going to move on to now this C term. This last number here is now going to be negative. That's what we'll see next. So star method, when basically your top is negative, and your C number is negative when AC, when you multiply AC, and that's negative. The only difference now, everything you can see here is exactly the same. The only difference is right here. The operation is not adding to get the B number. You're now subtracting to get the B number. Just like when we're doing our simple method, and when this was negative, we did a whole bunch of those earlier, we were subtracting to get the B number. What 2 numbers multiply to give us C, that's subtract to give us the B. That's what we were doing in the simple method. Now we're going to be doing what 2 numbers multiply to give us this number on top, that will subtract to give us the bottom number down below for the where to put the question marks right there. That will fill in those bottom parts on the sides. But everything else is exactly the same. So if this is negative, you're just going to have to subtract to get the bottom number. All right, let's go ahead and try a couple of these. I'll do 10 and 11, and again you can try 12 on your own. So starting with number 10. And again, I would always want to check to see, is there a GCF? 12, 5, and 2. There is no GCF between all those numbers, and there's no A's in all the terms either to factor anything out. So there's no way to factor anything out here. We're going to have to use a star method because it starts with a 12 here. So 12 times this negative 2 is a negative 24 for the top. 5, positive 5 is your B number for the bottom. And the way it starts is 12a, so 12a will go on the top of each side. And then you ask yourself the question, what 2 numbers multiply to give you 24? That's subtract to give you 5. And so we use these numbers before. 8 and 3. 8 and 3, they do give us 24 when we multiply. 8 minus 3 is 5. So 8 and 3 are the numbers. They're going to have to be different signs. The 8 and the 3 will be different signs because we're subtracting. The 8 that's bigger is going to get the sign of the bottom number 5. So 8 gets the positive, 3 gets the negative. Just like the simple method was the same idea. Same kind of thing happened there. The bigger number between the two always got the sign of the middle term. Middle term sign goes with the bigger number. Now I can reduce. 12 and 8 can reduce by 4. So 4 goes into 12 3 times, that's a 3a on top. 4 goes into 8 2 times, so plus 2 on the bottom. And then that's reduced there on that side. 12 and 3 can reduce because 3 can go into 12. So 3 goes into 12 4 times, 4a on top, and 3 goes into itself just once, so negative 1 on the bottom. And now this side is reduced. And so our two binomials then, as we put our two binomials down, this one can go in the first one here, 3a plus 2, and the other one's 4a minus 1. Again, the order of the binomials doesn't matter, just that the binomials are those two binomials. Let's take a look at number 11. So number 11, nothing to factor out. Again, there's no GCF to factor out, so we start with 15 times negative 8. So again, it's going to be a little bit bigger. 15 times an 8. We might want to use our calculator to help there. Just 15, because we'll probably need to use it again. Times 8. It's going to give us 120. And it's negative. Negative 120 on top. There's our b, positive 14. So plus 14 is at the bottom. The top of the sides is how did we begin? Number and letter. 15 and b. 15 b, 15 b. And now we ask that question. So this is just setting up the star. Then we ask the question to figure out what goes below the 15 b's. What two numbers multiply to give us 120? That will subtract to give us 14. All right, so obviously 15 and 8, will they subtract to give us 14? No, they won't. That'll be much less. We could try something else, maybe by 10, about 12 and 10. They're not going to subtract to give us 14. So let's go to our calculator and look at some other numbers here that would be maybe closer to give us a subtraction of 14. 20 goes into this. Let's try 20. So if I divide by 20, that's going to give me 6. So 20 and 6. So 20 times 6. Will those subtract to give me 14? And they will, yeah. 20 and 6 do. So I can use 20 and I can use 6. So that was easy. We got it kind of on the first try. You might have to try a few times before you find the right combination that will subtract to give you that number down below. Now what about the signs of the 20 and the 6? We know they got to be different because we're subtracting. The bigger one's going to get the positive from the 14. 20 is bigger than 6, so 6 gets negative. And now let's see, can we reduce? We can reduce over here by 5. So let's see, I'm going to erase this there so it's not confusing. So if I reduce this by 5, 5 goes into 15 3 times, so I get a 3b on top. 5 goes into 24 times, so positive 4 there. There's my reduced side. And then over here, 3 can go into both of these numbers. 3 goes into 15 5 times, so 5b on the top. 3 goes into 6 2 times, so negative 2 on the bottom. And there's my reduced side. And now we have our two binomials. 3b plus 4 in the one, and 5b minus 2 can go in the other. Again, you can always double check by just multiplying this with FOIL to see can you get back to the original trinomial. Alright, so now it's your turn. Go ahead and pause the video and try number 12. See if you can factor using the star method with number 12. Alright, so you should have paused the video and now you're just checking to see if your answer is correct. Let's check your answer first. Your answer should have been these two binomials, t plus 3 and 5t minus 3. We have t as our variable in this one, and so if you got that correct, then you must have done your star correct. If you didn't get those correct, and they don't have to be in that order, you could have put the 5t minus 3 first and the t plus 3 second, But if you didn't get this correct, let's see if you can figure out maybe where you went wrong. We're multiplying 5 times -9 for the top, positive 12 is at the bottom. It starts with a 5t on top of each side. The two numbers that multiply to give you 45 that subtract to give you 12 would be 15 and 3. So 15 times 3 is 45, and 15 minus 3 is 12. And they are going to be different signs. The 15 that's bigger is going to get the sign of 12. That means 3 is negative. So you can see even right there, 15 minus 3 does give you positive 12 for the middle one. And you can reduce each side. This one you're reducing by 5 to give you the t plus the 3. It's going to go in that first binomial there. And this one, you can't reduce. 5 over 3, there's no way to reduce it, so that just goes in your binomial. It's already reduced. So 5t minus 3 is already reduced there, and that's your binomial. So you only had to reduce just this one part here. All right, let's move on to our joke of the day. That's going to be next. So why did the farmer bury his money? That's our joke. That's our question. Why did the farmer bury his money? Well, because to make his soil rich. To make his soil rich. He buried the money to make the soil rich. Oh, of course. Rich soil. That's what farmers love. Farmers love rich soil. They need rich soil to grow their stuff. Well, that farmer apparently buried his money to get the rich soil. All right, moving on to page 233. We have 6 problems right here to do, just using the star method. But notice the difference on this one here is that every single trinomial starts off with a negative first term. And when you factor using like the star method or the simple method, you do not want to factor it with a negative first term. So what you need to do instead is factor out, that's why I put number 1 here, factor out negative sign. We're going to need to do that first, and then we can use the star method to factor what's left in that trinomial. So let's go ahead, I'll do the top 3, and then you're going to do 16 through 18 on your own. So starting out with just factoring out a negative sign. So factor out the negative sign. That's going to change all of these signs to their opposites. This will be now positive 12b squared, and then minus 5b, and then minus 2. And now we can factor this with the star. So 12 times negative 2, that's going to be negative 24, negative 5b down below from your middle term. And it starts with 12b. So 12b, and we're just going off what's in the parentheses because our negative sign's outside already. So 12b, and then 12b on the other side as well. So the two numbers, we've already used these numbers before. Two numbers that multiply to give you 24, that subtract to give you 5. That was 8 and 3. We saw that earlier. And so this time, they're different signs. 8's going to get the sign of the 5 here, which is negative. So 3 is positive. And we reduce each side here, this one by 4. So we get 3b on top and negative 2 on the bottom. There's our reduced side there. This one we can reduce by 3. So 4b on top and a positive 1 on the bottom. They're now going to put these in 2 binomials, but we don't want to forget that we factored out a negative. That negative's got to still stay in front of our 2 binomials. So in front of that first binomial is going to be the negative sign, and then you have a 3b minus 2 and a 4b plus 1. All right, let's take a look at number 14. Factor out the negative sign. So it just changes all the signs here first, minus x and a minus 15. And then we can factor using the star. 6 times 15, so 6 times 15 is 90. It's going to be negative 90. If you need to use a calculator for that, you can. And then we have a minus 1, a negative 1 for the middle one. 6x is the top of each side. That's how it begins with number and letter. Two numbers that multiply to give you 90, that will subtract to give you a 1. So what multiplies to give us 90, that's going to subtract to give us a 1. Obviously, when we thought of right here 6 and 15, that's not going to subtract to give us 1. But what about 9 and 10? 9 times 10. That's easy to think about. 9 times 10 is 90. 9 10 minus 9 is going to give us the 1. We're different signs. The bigger number is 10, so 10 is going to get the sign of the 1 there, negative, which means 9 is positive. We can reduce this side by 3. So 3 goes into 6 2 times, 2x on top, positive 3 on the bottom. So that's that side reduced. 6 and 10 can reduce by 2. So 2 goes into 6x. Oops, that's going to be a 3x right there on top, 3x. And then 2 goes into 10 5 times, so 3x on top and the 5 on the bottom. 2 binomials, but we can't forget that this started with a negative. Don't forget what you factored out, kind of a GCF sort of with that negative sign. So we had the 2x plus 3 and a 3x minus 5. Again, the order of those two binomials doesn't matter. Again, you can always check yourself. First terms give you that 6x squared. From here, outside and inside, that's going to give you 10x and 9x, so negative 10x, positive 9x gives you that negative x in the middle, and 3 times negative 5 is the negative 15. Okay, coming to number 15, factoring out negative sign. Now, if there was a common number, that would factor out a number with that negative sign as well. So just in case, you want to always look for a GCF with a number or even a letter, but right now it's just the negative sign coming out. So you had 60g squared plus 11g minus 1. And so you're going to multiply 60 times negative 1 is negative 60 on top. Positive 11 goes on the bottom. 60g is on the top of each side. And then we think of two numbers that multiply to give us 60 that will subtract to give us an 11. Let's see, well, there's a few different combinations. We can think of 6 and 10. That's not going to subtract to give us an 11 though. 12 and 5, that's also not going to subtract to give us 11. So let's see, what else could we use here? We can use a calculator also to kind of help us. We just put in 60 and then start to divide by things. We can think out what else could work here. So we already tried 10 and 6. We can put out maybe, it's got to be somewhere between 10 and 6, so maybe like 8. So here's one where, let's try all the factors here. Actually, I'm thinking let's do this. All the factors of 60. Let's work them out here. So we got 1 times, we have 1, we have 2 can go into it, 3 can go into it, 4 can go into it, 5, 6 can go into it, 7 does not go into 60, 8 does not go into 60, 9 does not, but then 6 times 10. And then we got to start going backwards. It was 5 times 12, it was 4 times 15, it was 3 times 20, 2 times 30, and then obviously 60. So what combination between these two would work? So remember, we can go opposites here. So 1 and 60, not going to work. 2 and 30, not going to, they have to subtract to give me 11. Nope. 3 and 15. Actually, no, 3 and 20, sorry. 3 and 20, that's 17, so no. 4, right here, 4 and 15. So there's the combination right there between those two numbers. 4, if I take 4 away from 15, that's 11. So that's the one we need. So that one, you know, you might have thought of it a lot faster, but if you can't think of it, that's one way you can do it, is you can just put all the factors of that number on top here, down here, and then just see the different combinations of what would multiply to give you 60 and which one will finally add to, or subtract, in this case subtract to give you the 11. So 60 and 15. 15 does go into 60. We know that's 4 times. So we can simplify here, but I need to get my signs here. They're different signs. 15 is bigger. It's going to be positive. 4 is a negative. And so it's going to be 15 goes into 60, 4g on top, and then just positive 1. And then right here, 4 does go into this one 15 times. So 15g, and then minus 1 here. So that's my simplified sides here. So the two binomials that we'll get, and don't forget to put the negative sign in front like we had here. We can see it's going to be right here 4g plus 1 and a 15g minus 1. Alright, so that's our answer on this one. I'm going to give you a chance to try the bottom three here. So same thing with factoring out a negative. Do that first and then use the star to factor what's left, but don't forget the negative sign to put in front of your answer there. Alright, so go ahead and pause the video and do 16 through 18 and then play it to just check those answers. Alright, so you should have hopefully answers for 16 through 18. So the first thing you would do is factor out the negative. Yeah, it just changes the sign. That's the easy part. For this one, let's go ahead and see what your answer should have been. So negative still out in front. You should have a d plus 2 and a 2d minus 3. That should be those two binomials. And if you didn't get that correct with those two binomials, that's what your star should look like. You can see if you made a mistake or see if you can figure out where you went wrong looking at my star. This one didn't have to be reduced, only this side did. Number 17, again factoring out the negative sign, leaves you with that trinomial. Your answer with the negative sign still out in front should be have an r plus 1 binomial and a 3r plus 1. So again, if you got those two, then your star was correct and you did it correctly. If you didn't get those two correct there, then again look at the star, look at my star there, and you can see maybe where you went wrong. And again, I didn't have to reduce this side. This side's already reduced. 3r plus the 1 was already reduced. And then number 18, negative sign comes out first. All the signs change to their opposites. Your answer should have that negative sign still out in front. And your two binomials, 2x minus 1, 4x minus 5. So that's what your two binomials should be. If you got something wrong, then again, try to check out what I did here on my star, see where you might have went wrong. Both had to be reduced on both sides to be able to get those binomials. Alright, let's just move on to our last two problems. So our final two problems for the lesson, and then we'll be done. And these are kind of more of a word problem situation. So for number 19, it's talking about the length of a rectangular shaped park. So the first idea is it's a rectangle shape. It says that it has the length of it is this expression 3x plus 5 miles. The width of it is the expression 2x plus 8 miles. And the area of this rectangular park is 360 square miles. And asking the question, what are the dimensions of the park? What is the length and what is the width of the park? Given this information. So what we're basically trying to do here is we need to find x, we need to find the value of x that's in those expressions, and then plug it in to figure out what the length is there and what the width is here. Alright, so what we need to know is the area formula for a rectangle. It's simply just length times width. So area A equals length times width. So I'm going to put the length times the width down in two binomials. So the two binomials are going to multiply each other. That's length times width, and it's going to equal the area 360. So it looks like something we're a little bit familiar with, but right now we need to solve the equation. So to solve this equation, we would need to solve it where this is equal to 0. So the first thing we're going to need to do is multiply. We need to multiply these two binomials. And we can do it just with FOIL or a double distributive property. So basically like 3x times 2x, so we'll do that here. So 3x times 2x would give us our 6x squared. The outside would be 3x times 8, that's a 24x. Inside right here, 2x times 5 is a 10x. And then the last term's 5 times 8, that's 40. And it's equal to the 360. And I'm going to clean this up here. I'm going to set it equal to 0, so I'm going to subtract 360 from both sides. So I'm going to have to combine 40 minus the 360 here, and I'm going to combine our two x terms here in the middle. So I'm going to start with 6x squared, and then we're going to say 34x from those two combined. And if I take 40 away from negative 360, that's a negative 320 equal to 0. And now what I do notice is that it does have a GCF here, but what I can do, I could factor out the GCF, or in an equation situation, I could divide every term by that GCF, which is 2. 2 is our GCF on this one, and I can divide out that every term here by 2, and that would give me a simplified equation. Now it's going to be up here. So if I, right here, 6 divided by 2, 34 divided by 2, 320 divided by 2 will give us now this equation, 3x squared plus 17x minus 160 equal to 0. And so now the way we'd solve this, we need this to become two binomials, so we can use the zero product property. But since it does start with a 3 here in front of x squared, we're going to use our star. So just like we've done before with star method, put the star down, we draw our star, and then we start with 3 times the negative 160 on the top is negative 480. Positive 17 goes at the bottom. 3x, the way this starts, is the top of each side. And then two numbers that multiply to give me 480 that will subtract to give me 17 is going to be our sides here. And so this one is a challenging one, like we've done before. 15 and 32. So, I went through this a couple times, maybe with a calculator here, and I got 480, trying to figure out, okay, well, what will multiply? Oops, still messed up. 480 on my calculator. There we go. So what numbers can go into 480? I thought of right here, 3 times 16 is 48. And if I put the 0 with the 3, that's 30 times 16. So I know 30 and 16, but will that subtract to give me 17? 30 minus 16, if I did that, actually, 30 minus 16, as you can see here, gives me 14. I'm not far away from 17, but those aren't the numbers. So I thought, okay, well, maybe something close to 16 is 15. Maybe 15 will go into this. So I try 15. 480 divided by 15, and it gave me exactly 32. So I know it went into 15 evenly. And when I said, okay, 32 minus 15 now, if I subtract them, it gives me 17. So that has to be the combination. So just use your calculator if it's these big numbers to try to help you. And then the bigger number is 32. That's going to get the sign of the 17. So that's positive. 15 is negative because they have to be different signs. We're subtracting. This side over here can be reduced to an x over a negative 5, reducing by 3. And this side over here can't be reduced. So now I'm going to put them in two binomials. One binomial is the x minus 5 for my reduced fraction, my reduced side here, and then 3x plus 32 on the other side that I didn't have to reduce. It was already reduced for me. Using zero product property, we can solve now. This binomial equal to 0 is just going to become x equals 5. And on this side, it's going to become a negative 32 over 3. So this one we don't want to use. We don't want to use this negative fraction. That's definitely not going to be it. So it can't be both of these. It can only be one of them. And this is the only one that's really going to make sense for it to be. So if you plug in 5 to your length right here, 3 times 5 plus 5 for length, that's going to be 15 plus 5, that's 20 miles for the length. And then if we plug in 5 here for the width, 2 times 5 plus 8, so 2 times 5 is 10, plus 8 is 18. So 20 miles is the length, 18 miles is the width. If you were to multiply those, 20 times 18, you do get 360. So that works. Number 20, this one's kind of an oddball one, why it's in our section here. We don't necessarily need to use factoring for this one. The sum of two numbers is 8. The sum of the squares of the two numbers is 34. What are the two numbers? It's kind of more of just a puzzle situation. But basically it's like this. Your two numbers are x and y. They might be different numbers. X plus y equals 8. And then if we square them, it's going to equal 34. So x squared plus y squared would equal 34. So basically we just need to figure out, two numbers that would add to give us 8, and that when we square those two numbers, they add to give us 34. So if you just think about, okay, what's the combinations that would add to give you an 8? So you can use 1 plus 7 equals 8. You can use either 2 plus 6 equals 8. 3 plus 5 is 8. And obviously 4 plus 4 is 8. Probably not going to be this one with the same numbers down here with two 4s. So now you could just try, okay, if I square the numbers, which one is going to actually add to give me 34? So if I start with the 1 and the 7 and do 1 squared plus 7 squared, well, that's 1 and that's 49. 1 plus 49 is 50. So that's not it. It's not 1 and 7. 2 and 6. 2 squared is 4. 6 squared is 36. 4 plus 36 is 40. So that's not it either. 3 and 5. 3 squared, that's going to give me 9. 5 squared is 25, and 25 plus 9 is 34. So there it is. Gonna ding, ding, ding. We found it. This one would be 32 with 4 squared and 4 squared. So your two numbers on this one, just from what we figured out, is 3 and 5. What are the two numbers? The two numbers are 3 and 5. All right, so that concludes our lesson here for 7.6, and I'll see you on the next one for 7.7. Have a great day.